Hey everyone, it's nice to see so many of you here in our Paramount Warsaw office. I hope that you enjoy your time here as much as we have to during our working hours. And the title of the talk is Slaying Nested Scrollables in Jetpack Compose. And it's a bit untypical, and it's on purpose, because I don't want to just talk, I want to invite you on an adventure. And whenever you're going on an adventure, you need a good guide, somebody who is smart, intelligent, somebody who you can rely on, somebody who knows answers to all of your questions, optionally handsome. And you, well, you got me. I'm sorry. My name is KAROL KSIONEK, and I'm Android engineer here at Paramount. I must say that I love Jetpack Compose, although this love is a tough one. It's platonic, let's make that clear, and one-sided. Like Jetpack Compose is giving me a hard time over and over, and I'm still here. To be honest, there's not much I can change besides the profession, right? Okay, every journey needs a plan. So, our plan for today would be, at first, we're going to collect some inventory from the forge of our blacksmith. After that, we're going to start the journey. So we'll go to the nearby forest to see what we can hunt there. And then we're going to fight this monster that we're about to face. And hopefully, like if everything goes according to the plan, we'll celebrate. But you know, everything can go wrong here. So, as a starter, we're going to talk about inventory. So everything that is necessary to slay the beasts that we're about to face. We don't want to look like that, so I'll just quickly show you what are the important things that we have to know about in order to proceed. So, first of all, Jetpack Compose, you all probably know it, is a UI declarative framework that allows us Android developers to create wonderful user interfaces. The great thing about it is that we no longer need XMLs. We can we can still be focused on our favorite programming language, which is Kotlin. Also, the great thing about it is that when we're using Kotlin multi-platform, we can also use Compose multi-platform and create a single application and deploy it on iOS, Android, web, and also desktop. So the most basic things that we're going to need, like I'll quickly go through it because most of you know it. So the most basic thing is a box, composable. Whenever we want to place something on top of another thing, we're using the box. So here we're placing the boxes one on top of another. If we want to display something below each other, we're using a column. Here we're placing 3 boxes inside of a column. And if we place 5 of them, like here, there's a small problem that the 4th element, like the last one, isn't visible to the user. And the user won't be able to see it unless we cast a spell. And spells in Jetpack Compose are called modifiers. So here we can see the vertical scroll modifier. And thanks to that, user is able to scroll the column and see the entire content of it. We also have a row here already with a spell, horizontal scroll applied, so the user can scroll in both directions. We also have a lazy counterparts of those layouts. So we have a lazy column and a lazy row. They're lazy, but they're lazy in a good way. Somebody need to explain that to my wife. So the laziness is about the fact that only the items that are visible on a screen are using resources. So they're only they are taking part of the composition. So if we have many items, like huge images, only those which are visible to the user are loaded to the memory, and only they are important. What is strange, maybe, about the lazy column and lazy row is the fact that in order to place something inside of it, we need to use some methods like item, items, and so on. Generally, items takes the number or a list of items. We also have lazy grids. Here we can see the lazy vertical grid with fixed amount of columns to 3 and some items inside of it. We also have the horizontal version of it, and yeah, that's it. What is important about those is the fact that they all have states. So whenever we want to control how they scroll, or we want to order them to scroll as we want, we need to have some kind of a handle to this lazy column or lazy vertical grid. And we can do it using a state. For lazy column and lazy row, we have lazy list state. And for lazy grids, we have lazy grid states. As you can see here, they're both having a layout info field. This field is granting us information about what items are currently visible to the user, what is the first visible item index, and so on and so forth. Many important things that we might be interested in soon. Those states also implement the interface called scrollable state. Here's how it looks like. It's entire interface, nothing more than that. So here we're having the scroll and dispatch row data methods. They are used to actually scroll the composable. And we also have 3 properties: is scroll in progress, can scroll forward, can scroll backward. Like, I think it's pretty clear what they do. Okay, so now our adventure begins. So we're leaving the town and we're going to the nearby forest. I'm trying to say something to you, but you're too excited to listen to me. So you're just walking and not listening to me. And when you finally saw the amazing, the beautiful forest of Paramount Plus, you're hypnotized. You can't see anything else. The beautiful trees, wonderful bushes. Birds are singing the most beautiful songs that you've ever heard. And here and there, you can see bugs. You know, bugs. Like there, you can see a bug that is chopping down the tree with a huge, gigantic axe. Like, you know, typical unexpected behavior of a bug. And yeah, suddenly you can hear a loud roar. I'm telling you that you shouldn't go there. No, stop, please, don't go there. I know what's this monster. It's the monster that was created by the one whose name cannot be spoken. Yeah, exactly. The one who's wielding in his hand the powerful artifact, the most powerful artifact of the realm, the Wand of Figma. Yes, he has created it because Figma grants him unlimited powers. But again, you're not listening. So you're running straight forward to see this. Behold the terrifying. Like, come on, what's terrifying here? Maybe it's behind it. What's wrong? Like, oh, my sweet summer children, you can see the danger when it's straight in front of you. So let me break it down for you. Okay. We're having here the screenshots from our Paramount Plus application. And on the left side, the mobile version, on the right side, TV version. And we should focus on the parts here. So below this Hub with Carousel Grid title, and the right side here. So although it doesn't look scary, let's see what we have here. So we're having the title. Below it, we're having a carousel of items. You could have never seen that because that's only in our application, like it's patented, right? And below, there's another title and another, let's call it a carousel with a presentation style of a grid. And on the right side, on the TV application, it's almost the same thing. So a title, a grid, a title, and another grid. What might also be important about it is that we're using paging here. So in case you don't know, whenever a user opens the application, opens this screen, we're loading, let's say, 10 carousels. And as the user scrolls down, we're loading more and more of them. Also, the same applies to items inside of a row. So first we load few of them, and as the user scrolls, we're loading more and more. And the same thing should apply to the grids. Okay, so let me show you how you could try to implement it. The most basic approach, like for now, let's forget about that paging, because the problem that I'm about to talk is going to also happen without it. So we're having the lazy column inside of it. Like we try to create the exactly that thing that is visible on the left side. Sorry, on the left side of the screen. So this mobile part. The lazy column. The first item of it would be the column with a title, lazy row with some items. If we launch the application like that, everything is working fine. Awesome, we done it. But now let's go further. Let's collapse this section and let's try to write something for the vertical grid. So here we're having another item with a column, the title, and a lazy vertical grid with some, let's say, 5 columns. And there are items. So the beast has noticed you. To be fair, you weren't very subtle with your charge, with swinging with your sword and trying to kill it. It spinned around and kicked you so hard that you fell out of the forest and you're lying close to the place where we've entered the forest. What has happened? Exception. It's so huge that it doesn't fit this huge screen. So our application has crashed. It's illegal state exception. Vertically scrollable component was measured with an infinity maximum height constraints, which is disallowed. One of the common reasons, and so on and so forth. So they even provided us information what might be the reasons for this crash. And yes, the fun fact is that you need to know that I really love doing code reviews. When I do code review, I can see what was the thought process going inside of a developer's head. So what was the code, and how did it change? How somebody changed this piece of code into something but different, okay? And here, this message gives me a glimpse of that feeling. Like, please take a look here. There could be other reasons for this to happen. Like, interesting thing is which word was first and which was added. I think I'm gonna observe what's the future of this message going to be. So, when you're lying down by the path, covered with blood and tears, you've realized something that I was showing you before, but you weren't listening. There's a sign by the path. As you come closer, you see there's a huge sign, a huge writing warning. You can see this. Avoid nesting components scrollable in the same direction. Okay, so we've been warned. Good to know, right? And another interesting thing is this word avoid. Like, there's a very subtle way of saying we'll crash your application otherwise, right? So, okay, what are our options in this situation? First of all, we can go back and try to kill the beast again and again and again, but that would be something like overcoming the framework limitations, right? Like they said it, avoid nesting scrollables. We could also go to the designer and ask him to change his mind, because that's the platform limitation. But come on, that looks very simple, right? It shouldn't be the platform limitation, and he would probably make jokes of us. So the other option that we can take is getting rid of paging inside of a grid. So right now, we could limit the height of the vertical grid so that it's not anymore infinity, it's fixed, and that would probably fix our problem. But not exactly, because you need to know that in Paramount plus Forest, there's also another powerful group of peoples, of warlocks. Yeah, they call themselves the testers. And if they would figure out that there's something like that, I'm sure that they would find a way to crash our application with it. Like, the first example that comes to my mind is, for example, the watch list. So the user can put some content to the watch list, and standard user, like, he would put there 20, 30 items, and that's all. But the tester, oh, whole different story. He could spend the entire day to add everything just to see our application crash. So, looks like the only option that is available to us is the first one. By the way, second and third are kind of relying on the human interactions. Yeah. Okay, so let's try to see the message that is inside of a Google developer documentation. So Google presents us code like that. So whenever we have a case like here, so we're having the column, which is vertically scrollable. Inside of it, we want to put the header, lazy column with some items, and some footer. Google is saying, instead of it, try to flattening it. So instead of having column inside of a lazy column inside of a column, let's try to have single lazy column, where the first item is a header, then we're having actual items from our, that before were in our lazy column, and then we have an item which is a footer. Well, it makes sense. Okay, right, why not? But does it apply to our situation? So here is an attempt of like something that we wrote before. So it's a lazy column with items of carousels. The carousels is our paginated list of items. In case you don't know how paging with Jetpack paging works and Jetpack Compose works, you're simply getting a list which is magically populated as you scroll down. Let's say like that. So we're iterating over the carousels list, and for each carousel we're displaying the column with a title and the lazy vertical grid. So that was the code that was crashing for us, right? So let's try to flatten it. Maybe to something like that. So lazy column with items from carousels, and for each carousel we'll display just title, and then we'll take the carousel items and display the items. Like that would change the order of everything. So we would first get the titles and then all the items. That's not what we want. Besides, we should probably have a lazy vertical grid here, something like that, okay? So it doesn't really work well in our case. Also, we're paginating over those carousels, right? So we don't have the list of carousel items available right away. We're having it on the go. So let's try another approach. Here, let's try to replicate, again, this screen from the left side on the right. And for that, let's imagine that on the right side we have a lazy vertical grid. But let's imagine that it's empty. I've just drawn those squares just to show that there's a skeleton, okay? So what we might want to do is kind of hacking it so that to display the first item with a title and a grid and a row, we're going to merge those three first items and display them somehow like that, okay? After that, we can take another three items, merge them together, display the title, and below it display the carousel items. So it would look somehow like that. Here, a small asterisk. It wouldn't work exactly as we design, as we think, because we have an API that allows us to scroll to concrete element of the lazy vertical grid. So, for example, we have an API, scroll to item index 7. And what we would expect, it would take us to the 7th carousel. But in fact, it wouldn't. It would take us to the 0, 1, 2, 3, 4, 5, 6, 7. Right? So to this 7th, to this last grid item. If that's fine for us, we can try to implement it. Let's go. So we're going to have a lazy vertical grid, which has 3 columns. The items are paginated carousels, and like for now, we always want to merge those carousels. So we're creating this span of size 3, and for each carousel. If carousel is not a grid, we're simply displaying the column, title, and a lazy row. If the carousel is a grid, we're displaying a column with a title and. Well, here what we're trying to do is we're trying to call the items of this upper vertical grid. It is possible, it is building, it is running. But depending on the data set that you have, you might get various behaviors. For example, you may encounter no issues until you start to scroll. When you start to scroll, everything will be messed up, and finally you will get the application non-responsive error. The other thing that might happen is presented here. So you might get illegal state exception, place was called on a node which was placed already. So there's a problem because the items normally aren't called from the composable scope. And here they would be, like here in the lower part of the screen. So this solution is completely unacceptable. Let's go further. Here we're having the code that we had initially, like more or less. And if we could only ask some oracle about the solution for this problem. And fortunately, we have such oracles. We have ChatGPT, we have Gemini, and we have Stack Overflow. So I've tried looking for an answer for this problem on those three platforms, and they all said, just set the fixed height of the lazy vertical grid, and you're done. It will work. Okay, let's see if they're right. So here we're having the lazy vertical grid with 3 items inside of it. Let's add another one. Ooh, that's not exactly what we wanted. Let's add the background to those lazy vertical grids so that we could better see what's wrong here. Okay, so our items are lower than the height of the lazy vertical grid. So simply there's a space between them. If we add more items to our lazy vertical grids, it looks even worse. The user can scroll it. It's terrible, like unacceptable thing. At this moment, it might be tempting to try setting the height to something really huge. Okay, and we could say, okay, that since it's a hard thing to do, maybe we could say to the designers and to the CMS team that they could set those grid carousels as the last items. So even if there's something below them, nobody will scroll there. So it would look somehow like that, right? Such an idea, 20 million DPs. And let's run the application. Unfortunately, nope, it won't work. We got illegal argument exception, can't represent a width of 0 and height of 13 million pixels in constraints. In fact, that's not the value which is a limit. That's the value of 20 million DPs converted to pixels. So we don't even know where's the border between the safe and unsafe values. Cool. Now we can learn another spell. This spell is called height in. It has 2 parameters, minimum and maximum. Here you can see only one of them. By default, the minimum is 0 dp, maximum infinity. So here we can set it somehow like that. And let's see how would it behave. So for 20 dp, it would look like that. So our lazy vertical grid is cut off. If we increase it to, let's say, 2000 dp, assuming that's the safe value, we'll get something like that. Cool, finally something what we wanted. Let's add another lazy vertical grid below. Awesome, that's what we wanted. Let's add more items. Great, even more? Okay, looks pretty well. Let's start to scroll it. Also, great, looks like we found it. Just keeping in mind that we may get so many items that they finally won't fit inside of this limit. But yeah, maybe there's some safe value that we could use, and it would be working. But there's also one problem with this solution. Here's the screenshot of our web debugging tool, Charles. so that we could see what's going on underneath in our application in terms of network traffic. So at first we're starting to load our watch list. It got loaded. It loads more. Somebody make it stop. It doesn't stop. Why? Because as I said, we've used the modifier, hide in. So here we have the minimum from the hide in modifier, 0 dp. Here we have the maximum. Sorry, I lost it. Here, 2000 dps. Let's assume that the red border is what we can see as a users. If we start loading the items, they will finally appear. There's still place on the screen, so it loads further. There's still place inside of the lazy vertical grid, so it still loads further and further and further and further, and finally we're done. There will be no more loads unless we start to scroll, of course. That's not what we want. Like, really, that's not it. Now, a little small spoiler, that's the final solution. So if we could think of the value that is safe in all cases, well, that's the height of the screen. Like, user will never ever see more items than on the screen. So let's limit the height of the lazy vertical grid to the height of a screen. So in this case, to the viewport size height, right? Thanks to that, we will get something like this. So we're having the first lazy vertical grid with 3 items, then another one with more items. If we add more items to the first one, it still looks fine. If we add even more, it starts to look not that good when we start to scroll. By the way, important thing is that right now user can start 2 kinds of scroll gestures. He can start scroll here on this gray area, and this way he will scroll the lazy column, so the outer composable. And if we start scrolling here, he would scroll the lazy vertical grid. So there are 2 kinds of scrolls. Yeah. As you can see here we're scrolling the lazy column, and here we're scrolling the lazy vertical grid. Now we're again scrolling the lazy column. Okay. If we could only, in some magical way, find a way of manipulating which composable is scrolled, there is a way. There is a way, and it's a spell called nested scroll. It's pretty well documented by Google. So I won't dig into the details. I'll just show you the overall idea behind the process. So whenever we have a child which is scrollable, and we start to user starts to scroll it, before the scroll actually happens, the child is sending the events in the top direction in the nested scroll hierarchy to all his parents that take part of that hierarchy. So in here we have 2 parents of the child. Let's say that the user has scrolled by the 20 pixels. Each parent can decide, each parent will get information about how many pixels we were scrolled, we try to scroll, and he would be able to decide. He can do nothing about it, completely ignore the value and just pass it further. He can take a look at it, so pick it and do something else without modifying the value for the parents up in the hierarchy. Or he can say, I'm going to take some of those pixels, and yeah, I'm going to consume them. So for example, here, let's say that the parent 1 took 10 pixels from the initial 20. The parent 2 will get information, hey, there are 10 pixels, maybe you want some of them. No, I'm fine, thanks. So that we're going to reach the root of the nested scroll hierarchy with the 10 pixels. Then those 10 pixels will be sent back to the child so that he can consume it, so scroll itself. And afterwards, the same process goes for the post-scroll. So the child is saying, hey, I've scrolled, and passing the information to the parents. How to implement it in code? It would somehow like that. We need to create the nested scroll connection. which is an implementation of a nested scroll connection interface, and we need to pass it to the nested scroll modifier. And the nested scroll connection interface has 4 methods. For us, the only one that is important would be the onPrescroll. It gives us access to available offset, so how much the user wants to scroll, and the source. Unfortunately, it's not the source like the composable which the gesture was started on. It's just information if it's the user-originated action or system-originated. Also, the important thing about nested scroll is what's the visibility of it. So let's say that we have 4 nested columns inside of each other. They all are scrollable. They all have fixed height. Yeah. And if we apply the nested scroll modifier to the most inner one, we're going to get informed about the scroll events happening to this red part, so the most inner column. If we move it higher, we're going to get more and more information. Something maybe interesting is that if there is something that is not scrollable above our scrollables, it may also get information about scrolls happening in its children. So yeah, so how do we really want to dispatch that scrolling data? Here, let's imagine that that's the screen of our device. I'm gonna draw here the more than we can see, so that we will be able to see what's happening behind the under the hood. So we're gonna display 2 lazy vertical grids with many items, and in this case, in this situation, we want to scroll the first grid until we can scroll it. So we're passing the scroll offset only to the first vertical grid. After that, we cannot scroll this lazy vertical grid anymore. So let's pass those delta to the lazy column. And now, when we're at the situation where second lazy vertical grid is at the very top of the screen, we can stop scrolling the lazy column and start scrolling the lazy vertical grid. Makes sense, right? The same thing would work if we scroll upwards, right? Cool, looks like we've got it. In terms of code, it would look somehow like that. So we need to create the lazy column state. We need to create something that would keep information about the lazy grid states, because like I said, we're using paging, so we don't know at the beginning how many grids we will get from backend. So we need some kind of a separate class which will be responsible for creating and storing the states of the grids. We also need to know what's the height of the viewport size. And below that, we have a code for the lazy column. We're passing the to the nested scroll, we're passing the nested scroll connection that we created above. We're using the lazy column state, and we're going through the items with index, because we need it here in getOrCreateState for grid method. So thanks to this method, we're simply getting or creating the state for this given grid. We're limiting the height to height of the viewport and displaying our items here. And the last thing that from code that I want to show is how our nested vertical grid scroll connection is looking like. So it's taking 2 parameters, lazy list state of our outer composable and inner scrollable states. And in onPrescroll method, what we do is we're checking how much do we want to scroll and which composable we want to scroll. Why do we need to decide how much to scroll? Like, why can't we take entire value from the available offset? There might be the case where we're when we have multiple vertical grids that have many items, and we might get into the situation where the top of the screen is between 2 grids. And if the user performs really quick gesture, like let's say 200 pixels, we might scroll that lazy column by 200 pixels, which would cause the lazy vertical grid, the second lazy vertical grid, wouldn't be at the top of the screen, and we would simply have a broken UI. Yeah. So that's it. And as I said at the very beginning, Compose is something which is multi-platform, like Compose may be multi-platform, right? So if the same code can run on iOS, web, Android, and desktop, it means that for sure the same code will run just fine when launched on the Android device mobile and Android TV, right? Right? Let me show you a movie. So here we have a movie of an Android emulator of the screen that you've already seen. We're gonna focus this item. Right now the focus is here. We're gonna move it here, and then we'll simply scroll all the way down. Cool. Whoa. What has just happened? We're still at the very end of the scrollable, but the focus has moved. Like here you could see some junky UI, right? And again, it's moving all the way up. This behavior is caused by something which is called local view spec, local bring into view spec, and it's a whole different story. So I'm not gonna talk about it today. And yeah, if you're interested in the full solution and the code that stands for it, like the complete code, because that was just a draft, you can see it soon on our Paramount Tech blog. And yeah, that would be it from me. Thank you.
Hey, so first thank you for the talk. It was really, really interesting. We actually faced a similar issue on an iOS app. And I was wondering like if the lazy V-grid that are like implemented in Compose are also facing the same kind of memory leak issues that you're getting with native component in SwiftUI. Like basically when you have multiple images and really a lot of images like you were showing, at some point when you use just native component, the whole memory tree is not lazy anymore, and it kind of keeps just like adding up to the memory instead of like caching.
So not that I heard of.
so it's passing in Compose, it's working.
Yeah, I think so. I haven't seen any reports on memory leaks like that.
All right.
Yeah, so that's the argument for iOS developers to go fully Compose.
Yeah, so there was nothing to say.
Hi, thanks for your talk. Just a small suggestion, because I was working on a similar issue with collapsing app bars. There was also a nesting scroll issue. I was talking with Google guys for a few weeks about that. My suggestion was when you have such a nested scroll connection object, which is on your UI layer, in some point when you have some more complex calculations with your deltas, these objects get pretty big in terms of calculations, and unfortunately it's a more or less a UI layer object, which is pretty hard to unit test, and this is kind of problem. So my suggestion to that was to pass that logic to the dedicated view model that can be reused on different screens, and in nested scroll connection object you can just pass lambdas or some callbacks. So this type of object is pretty dumb this way, and you can unit test your view model in Android more easily. Thanks.
Yeah, thanks for the suggestion.